Welcome everyone. In this video, we're going to go over this problem number 2, section 4.1, and basically it's proving vector spaces. That's about proving vector spaces. So in this problem, you're given a rational function p of x over q of x, and the vector addition is given by this formula. So p1 of x over q1 of x plus, let's just call it plus p2 of x over q2 of x. And you have that formula, p1 of x times q2 of x plus p2 of x times q1 of x over q1 of x times q2 of x. And the scalar multiplication is given by this formula, k scalar p of x over q of x is k times p of x over q of x. Now we want to prove that this is a vector space. So we're going to go over all the 10 axioms. Well, the 10 axioms, I have it here. I'm going to go over those one by one and show you how it works for this one. But before doing that, it says there's a warm up. You have 3 over x plus 3 plus 2x plus 24 over x squared minus 9. And you have negative 3 times 5x minus 7 over 6x plus 9. So in this case, p1 of x is 3, q1 of x is x plus 3, p2 of x is 2x plus 24, and q2 of x is x squared minus 9. Basically, you just substitute. So the vector addition is going to be 3 times that q2 of x is right here, plus then we have p2 of x, which is 2x plus 24 times x plus 3. And again, if you factor out and simplify this, the answer, the final answer is going to be 5 over x minus 3. These are simple simplifications actually, so some little algebra. And negative 3 scalar 5x minus 7 over 6x plus 9. In this case, p of x is 5x minus 7, q of x is 6x plus 9, and our k is negative 3. So if we substitute, then we know that's going to be, actually the formula is here. Let me show it to you again. So that's what we have to use, which is pretty simple. So it's going to be negative 3 times 5x minus 7 over 6x plus 9. That's negative 3 times 5x minus 7. Then you can factor out the 3 here times 2x plus 3, and you're left with minus 5x minus 7 divided by 2x plus 3, negative 5x plus 7 divided by 2x plus 3. Now, if you go over the axioms one by one, the first one, it says u plus v should be in v. Let's see if that works. So if we do the vector addition, this is what we get. So we already saw the formula. Now, when you do that, you get another polynomial, because this is a polynomial itself over, and q1 of x and q2 of x is also a polynomial. So a polynomial over a polynomial, it will give you a rational function, and that's the goal. We have to get a rational function when we do the vector addition, so we can say it's closed under addition. When you do k scalar p of x over q of x, you get that, or I wrote it again here, and that's also a rational function, so it's closed under scalar multiplication 2, and that's the goal. When you do the scalar multiplication, you need to get a similar, in this case, function which has to be a rational function like r of x. The commutative property or commutativity of addition, so we have that one. We can start p1 of x over q1 of x plus p2 of x over q2 of x. We have that. We can simply switch the places. So we can write this as q1 of x, p2 of x times q1 of x plus p1 of x times q2 of x divided by q2 of x times q1 of x, and that becomes, this is just p2 of x over q2 of x plus p1 of x over q1 of x. So that checks. Number 4, it's kind of long, but I did part of it. So associative property, you should start the same way. So we have to have that. So you write again the first two of them, rational functions, and of course the vector addition is going to give us that. So then it's plus P3 of x, Q3 of x. Then you can evaluate that is again this times that, which I wrote it here. And it's going to be 3 of x times that. And if you simplify or multiply and distribute all this, you get this expression and you can arrange it. Again, these are simple line calculations, but I didn't go over that. Please try to finish this yourself. But if you do that, you can for sure write that as P1 of x over Q1 of x plus parenthesis P2 of x over Q2 of x plus P3 of x over Q3 of x. So it's associative. Now the identity, the additive identity, again, that's the zero vector. If we put 0 here, then we get P1 of x times 1. That's, imagine it's 0 over 1 and Q1 of x times 0. So this is 0, you just get the same thing. So in this case, 0 is the identity. Next one is additive inverse. Let's try this. So if we do P1 of x over Q1 of x plus negative P1 of x over Q1 of x, so you get P1 of x, Q1 of x minus P1 of x, Q1 of x. These two cancel and you get 0, which was the additive inverse. So we do have it. So that is satisfied also. So let's see, distributive property R plus S scalar V should be R scalar V plus S scalar V. Write it just the same way. R plus S scalar P of x over Q of x is R plus S times P of x over Q of x. That's R times P of x over Q of x plus S times P of x over Q of x. And that just becomes R times P of x or R scalar P of x over Q of x plus S scalar P of x over Q of x. So that's satisfied. Then we have the distributive property R dot U plus V. So we can say R dot P of x over Q of x plus P2 of x over Q of x. And again, this is R times, and you know what that is. You just write it. And you can just go the right side here. If you write that one, so what we get is R scalar P of x over P1 of x over Q1 of x plus R scalar P1 of x over Q1 P2 of x over Q2 of x. Let me fix that. So we get R P1 of x Q1 of x plus R P2 of x over Q2 of x. And again, these are simple. It's going to be that times that plus that times that, and we have the R. Then we can factor out R, which is going to be, if we do that, that becomes the same thing as number 1, which is right here. So number 8 works. Then number 9, the associativity of scalar multiplication. This is exactly like number 8. You can say R, again, scalar times S scalar P of x over Q of x. That's R scalar S times P of x over Q of x. And that just R times S scalar P of x over Q of x the same way. And that's Rx times P of x over Q of x. So they all give the same answer. And finally, 1, if you do 1 scalar P of x over Q of x, that's 1 times P of x over Q of x, and that's P of x over Q of x. And all 10 of them are satisfied. So this is a vector space. I think that's it for this video. Please watch it a couple of times. There's some calculations are long, but they all work the same way. I have some other videos on this. Watch those too. And I think if you practice 3-4 of those, then you become very familiar with them. Thank you for watching, and I'll see you in my next video. Have a good one.